Hi all. So today in our statistic class, we are going to learn and discuss about correlation in chapter 9a. So what is correlation? So correlation is the analysis uh, that is a statistical method used to evaluate the strength of relationship between the two quantitative variables. Okay, so correlation is refer to the correlation analysis. Okay, so correlation analysis is a statistical method used to evaluate the strength of relationship between two quantitative variables. Okay, so in correlation analysis, a high correlation means that two or more variables have a strong relationship with each other. Okay, and a weak correlation means that the variables are hardly related or not related. Okay, so in correlation analysis, okay, they have been divided into univariate and bivariate statistic or univariate and bivariate analysis. Okay, there are also another one that is multivariate analysis. Okay, but we are focused more to bivariate analysis. Okay, usually for univariate analysis, it refers to the measurement of the frequency distributions, the mean, mode, range, and standard deviation. Okay, and for univariate analysis, okay, it is referred to the analysis of one variable. Okay, for example, okay, you maybe want to study a group of college students to find out their average exam scores. Okay, in this example, a group of college students, okay, is one variable, and to find out their average exam scores, so the average exam scores is another one, uh, sub-variables. Okay, or maybe another example, it refer to, for example, you want to study about a group of diabetic patients to find out their weights. Okay, so this is the univariate analysis or univariate data. It only contains one variable. But for bivariate, so bivariate or bivariate analysis is a refer to the analysis of two variables. Okay, for example, you might want to study a group of college students to find out their average exam scores and their age. So now it refers to two data. That means average exam score and age. So that is the bivariate data. Okay. So what is correlation? So correlation also can refer to the linear pattern of relationship between one variable and another variable, that is x and y. So in correlation, actually we want to measure the relationship or to test the relationship between two variables. Okay, that is x and y. And usually x variable is also referred to independent variable, and y variable is also referred to the dependent variable. Okay. However, in correlations analysis, although we can test the relationship between two variables, okay, but we cannot prove the causality effect. Okay, that means we cannot assume that maybe variable X causes or predict to variable Y. Or we cannot say also that variable Y causes to variable X. That means we cannot assume the relationship have the causality effect. Okay, we just only can test the relationship between two variables in terms of their strength. Okay, either it is strong, weak, or no relation. But we cannot say that the x variable, for example, will cause variable y increase, or variable y will cause the variable x increase. That means we cannot predict their causality effect, the cause and effect. Okay, so that is the correlation. So, as I said, correlation coefficient is the measurement or the test that we want to test or measure the strength of the relationship between variable x and variable y. So this is the formula for Pearson's correlation coefficient. So it refers to R. So R equal to S xy divided by square root s x x times s y y. Okay, so x is referred to the first variable and y is referred to the other variable. Okay, so this is all the formula that we are going to use, and we will test to use this all formula in our example. Okay, we will see later. So Pearson correlation coefficient is referred to R, that indicates the strength of relationship. Okay, that is a strong, weak, or no relationship. And it also will predict the direction of relationship. That means it can be the positive or direct relationship if the variables move in the same direction. But the direction of relationship will be negative or inverse if the variables move in opposite directions. So R will range in value from negative 1.0 to positive 1.0. So negative 1.0 will refer to strong negative, and 0.0 is considered as no relationship, and positive 1.0 is considered as strong positive. Okay. How we are going to say that the direction of relationship is a positive relationship? Okay, so let's see this example. Okay, let's say the first variable is burn out. Okay, the first variable is burn out. Okay, and the second variable or the outcome variable is depression. Okay, now we have two variables and we want to test the relationship between these two variables. That means between burnout and depression. Okay, now burnout is referred to the negative psychological health condition, isn't it? And burnout is also referred to the negative psychological health condition. So in these situations, the variables is in the same direction because it is same. It is in the same dimension or in the same condition. It refers to the negative psychological health conditions. Okay, so we can say that the burnout have a positive relationship or have no positive relationship with depression. So this one, we are going to say that the direction is in positive direction because the variables is moved in the same direction. Negative, burnout is negative, depression is also negative. So it moves in the same direction. So we are going to say that this direction is in positive direction or positive relationship. Okay, let's say we are going to test the correlation relationship between burnout and the other one is happiness, for example. Okay, happy. Okay, now in this condition, burnout is referred to the negative psychological health conditions. But now, okay, in contrast, happiness or happy is referred to the positive psychological health condition. So it moves from the positive to the negative directions. Sorry, it moves from the negative direction to the positive direction. That means burnout is referred to the negative conditions and happiness is referred to the positive conditions. So it moves in the opposite directions. So we are going to say that this relationship is in negative direction or negative relationship. Okay, same also if the predictor variable is happy. Okay, happy, and we want to predict, for example, let's say burnout. So now happiness is in positive psychological health conditions, so in positive conditions. But now burnout is negative psychological health conditions. Okay, so it moved from positive conditions to the negative conditions. So it moved into the opposite directions. So we are going to say that this direction will going to be the negative direction or in a negative relationship. Okay, so that is the direction of relationship in Pearson correlation coefficient. Okay. All right. However, correlation also have their limitations. The first one is it cannot describe the non-linear relationship. So it means, for example, okay, if the correlation coefficient of the two variables is 0, so it shows that there is no linear relationship between the variables. Okay, so if the correlation coefficient of two variables is 0, so it shows that there is no linear relationship between the two variables. So if there is no linear relationship between the variables, so we cannot describe the nonlinear relationship. Okay. Okay, however, okay, this is only for a linear relationship. Okay, but maybe for curvilinear relationship, curve, okay, curvilinear relationship, maybe there is a possibility that the variable have strong relationship. Okay, but it not works for nonlinear relationship. Okay, let's say the relationship between anxiety and performance. Okay, let's say we test the relationship between anxiety and performance. Okay, and then we found that the correlation is at maybe 0.0005. Okay, so this means that there is no correlation because it approaching to 0.00. So this situation shows that there is no correlation or no relationship between anxiety and performance. Okay, so we cannot describe the nonlinear relationship if there is no relationship or correlation between anxiety and performance. Okay, and also it cannot prove the causality effect or the causation effect. That means we cannot assume that X causes Y or Y causes Z. Okay, it just shows the strength of the relationship between two variables. Either it is strong, weak, or no relations, and either it is in positive relationship or negative relationship. But we cannot assume that the variable X may be cause variable Y or variable Y causes variable X. We cannot say that because we have no proof of causality effect. Okay, so this is some correlation patterns. Okay, if you try to run the correlation analysis in, for example, in SPSS software or another software like SAS software or macro software, okay, you can see the software will run the analysis for you and will interpret the results based on the graph. So for example, this is the linear relationship and this is for curvilinear relationship. Okay. And this is the conditions for strong relationship, and this one is for weak relationship. Okay, if you see if the relationship is strong, the distribution is quite closer to each other. Okay, it's quite closer to each other. But if the relationship, the correlation shows that the relationship is weak, okay, the distribution is quite far from each other. It's quite far from each other. Okay. Okay, now let's see the examples. Okay, the table shows the heights and weights of n equal to 10 randomly selected college football players. So is there a significant positive correlation? Okay, is there a significant positive correlation between weight and height in the population of all college football players? Okay, now they give you the value of the height and weight for 10 college football players. Okay, so now how we are going to get this R value, that is 0.8261. Okay, you can refer to the R or the correlation coefficient formula. Okay, so but first of all, you must get the value of SXX, and then SXY, and then SXY. Okay, so now the first step, we must get the average mean for the value of X or X variable, that is H. Okay, so how to get the average? So you must count, total up the value of 73 plus 71 plus 75 plus 72 until the rest of 10 players, that is 69, and divide by 10. Okay, so you will get the average mean for H or X bar is equal to 71.4. Okay, and then you get the average mean for variable y or weight. So you total up 185, 175, 200 until 175 and divide by 10. Okay, so you will get 183. Okay, so this is the value of the y bar or the mean, the average mean for variable y. Okay. Okay. Now this is the table, the same table from the previous slide or previous example. Okay. That means the height is referred to the variable x and weight is referred to the variable y, because we want to see the or to test the correlation between height and weight of football player. Okay, now we have the value of average mean for x, that is 71.4, and y is 183. Okay, now you must get the total value for x minus x bar. So x is, for example, now x refer to 73. So x bar is referred to 71.4. So 73, this one, minus 71.4, then you will get 1.6. Okay, and then again x is referred to 71, and then minus with x bar, that is 71.4. Okay, then you will get negative 0.4. Okay, so you continue for 75, 72 until 69. Okay, and then you will get all this value. Okay, and then next you must get the value of y minus y bar. So the same formula like x variable. Okay, so the y variable is 185 minus y bar is referred to 183. Okay, so 185 minus 183, then you will get 2. And then continue with 175 minus 183, and then you will get negative 8. So continue for 200 210 until 175 minus with 183. So you will get all these value. Okay, now you must get the value of x minus x bar times with y minus y bar. So now x bar is, for example, 1.6, and then you must times with y minus y bar, that is 2. So 1.6 times with 2, you will get 3.2. And then negative 0.4 times with negative 8. Okay, negative 0.4 times with negative 8, then you will get 3.2. And then you continuous for 3.6 times with 17, you will get 61.2. And do the rest for all these value. Okay, so you will get all this value. Okay, continue to times the value of x minus x bar with y minus y bar. And then you total up all this value, then you will get the total value is 328. Okay, and then you must get also the value of x minus x bar square. So x minus x bar is, for example, 1.6. This one. X minus x bar is 1.6. So you 1.6 square. Okay, 1.6 square. Then you will get 2.56. And then negative 0.4 square. Okay, you will get 0.16. You will get actually negative. Okay, negative 0.16. But for these conditions, okay, this one, and this one, you are going to ignore the negative value. Okay. So ignore the negative value. Okay. And then you continue for 3.6 square, you will get 12.96. So continue for the rest of the value and then total up the value. For x minus x bar square, you will get 60.4. Okay. And the last part, you must also get the value of y minus y bar square. So y minus y bar, for example, 2, and then you square, you will get 4. Okay, and then negative y, and negative 8, sorry, negative 8 square, then you will get negative 64. Or when you ignore the negative, it should be 64. And then you continue for the rest of the value of y minus y bar square, and you total up, you will get 2610. Okay, so remember, you must ignore the negative value when you total up all the value for x minus x bar square and y minus y bar square. Okay, so now you get the value of x minus x bar times y minus y bar. Okay, and then you also get the value of x minus x bar square and y minus y bar square. Okay, now after we get all this value, we can proceed to convert all this value into the R formula. Okay, so this is the R formula. So R formula is referred to the total or the sum value of x, y divided by square root s, x, s and s, y, y. So the above value, that is s, x, y, is also referred to the sum total of x minus x bar times y minus y bar. And s, s, x, s is also referred to the sum of total for x minus x bar square. And s, y, y is referred to the sum of y minus y bar square. Okay, now convert all the value that we have counted earlier, okay, into this formula. So we get the value of R is 0.8261. Okay, 0.8261. So if you try to run in, for example, SPSS analysis software, okay, you will see the plot of the distributions. For example, we get 0.8261, isn't it? So 0.8261 is considered have a strong positive correlations because the distribution is in strong or positive directions. Okay, so because the distribution is quite close between each other. Okay, and actually for R equals 0.8261 or 0.8 is actually strong. The correlation is strong. Okay, and if you refer to R value, okay, usually most of the researcher or the academician believe that 0.5 and above usually considered to have a strong positive correlations. Okay, so when we got R, that is 0.8261, okay, so it is considered as strong positive correlations. Okay, so we can state that as the player's head increases, so the weight is also increases. Okay. Okay, now after we get the value of R, we can continue to the statistic. So the population of coefficient of correlations is called rho, RHO. Okay, so this symbol is called rho. So the population coefficient of correlation is called rho. So we can test for a significant correlation between X and Y using a t-test. Okay. Okay, now after we got the value of R, okay, that is 0.8261, we can continue to the test statistic. Okay, but as most of the previous analysis that we have discussed in our previous lessons, we must state the null and alternative hypothesis. Okay, so for correlation coefficient, we are going to state that P, this is not P, sorry, this is a rho. So we are going to say that rho is equal to 0 for null hypothesis. And for H1 or alternative hypothesis, we are going to say that rho is not equal to 0. Okay, now we can move to the next step, that is the test statistic. So now we are going to test the statistic. It refers to T. Okay, so how to test statistic using the correlation coefficients? So it is T equal to R square root n minus 2 divided by 1 minus R square or rho square. Okay, so we are going to reject the null hypothesis if the T value of test statistic is greater than the T critical value alpha divided by 2 or T less than negative T alpha divided by 2 with n minus 2 TF. That means the degree of freedom is referred to the value of sample minus 2. Okay, so this is the formula to test the test statistic for correlation coefficient. Okay, now we already get the value of R that we have calculated before. Okay, now the question said that is there a significant positive correlation between weight and height in the population of all college football players? Okay, so now we have stated the null hypothesis and the alternative hypothesis. Okay, let's say the hypothesis for null hypothesis is referred to rho equal to 0, and the alternative hypothesis is referred to rho greater than 0. Okay, in questions, usually they will give a clue. Either the rho should be greater than 0 or less than 0. But now in these questions, it wants you to get the alternative hypothesis that is a rho greater than 0. Okay, so now the test statistic is T equal to R. So R value we already get from our previous calculation, that is 0.8261. So just insert the value here, 0.8261. Okay, and then square root with n. N is the total of sample. So the total sample of football players is 10. So 10 minus 2 is equal to 8. And then 1 minus R. So again, R is 0.8261 square. So 1 minus 0.8261 square. So the final answer, we will get the test statistic of T for correlation coefficient is 4.15. Okay, now we must refer to the T table. Okay, so for correlation coefficient test statistic, when we want to do the comparison, we must refer to the T table. Okay, the T table, I cannot provide to you the T table as I provide for you the another table. Okay, another table I can upload and provide to you. But for T table, you must refer to the online table. Okay, you just search the T distribution table. So it will appear in online table, in the form of online table. Okay, so usually in T distribution table, it will have the value of degree of freedom, and it will have the value of alpha or significant level for one tail and two tail. Okay, all right, so now back to the example, to these questions. Okay, now we get the value of T test statistic is 4.15. Okay, 4.15. Okay, so now we use the T table with n minus 2 equal to 8, the degree of freedom. So the degree of freedom is 8. Okay, to bound the p-value as p-value less than 0.05. So now the question want you to compare with the alpha or p-value 0.005. Okay. And the question also want you to use one-tailed t distribution. Okay. In t table, they will have one-tailed t distribution, and it also have the two-tailed t distributions alpha level. So now in this example, they want you to use the one-tailed t distributions value at alpha 0.05. Okay, so now you can refer to the t distribution table that refer to the one-tailed distribution, and the alpha is 0.005 and the df is 8. Okay, so when you refer to t distribution table, you will get the critical value of t is 3.355. So now the cutoff is the critical value is 3.355, and our test statistic is 4.15. That means greater than the critical value of t, 3.355. So it falls in the rejection region. So what we can conclude? We can conclude that we reject the null hypothesis, okay, because the t test statistic value is more than the critical t value, that is 3.355. So we can conclude there is a significant positive correlation between weight and height in the population of all college football players. So now it is important for you to conclude a significant positive correlation. You must state the significant positive correlation, because the question said they want you to test the correlation test statistic in terms of positive correlation. Okay, if you refer back to the question, it stated that the question said that is there a significant positive correlation between weight and height? So for the conclusion, you must state that if there is a significant correlation, you must state the direction also, because the question said about the direction, that is the positive direction or positive relation. So you must state at the conclusion section, there is a significant positive correlation. Okay, you must state the significant positive correlation. Not only, you cannot only state that there is a significant correlation or there is a significant positive, but you must state there is a significant positive correlation. Okay, because it refers to the questions. Okay, so that's all for correlations, coefficients, calculation analysis. Okay, so first of all, you must get the value of R. Okay, and then after you get the value of R, you can start to state your null and alternative hypothesis and test your test statistic T. And then when you find your value of T statistic test, you must compare the value with the critical value of T in T distribution table with the alpha level and also the tail that have been given. Okay, so please also refer to these lecture notes, and also I will also provide the other short video that will show you another example for the correlation calculations. and I will upload both the lecture notes and the other examples of the short videos in Putra Blast, so you can refer to it. And if you have any questions that you might want to ask me, or you have any concerns or anything that you want to discuss, please do ask me. Okay, so thank you, and I wish you all the best.